Vertical farming is a game-changing approach to agriculture that grows crops in stacked layers, often in urban environments. This controlled environment allows for much higher yields, up to 10 times more than traditional farming methods. Vertical farming addresses critical food security challenges by bringing agriculture closer to where people live and consume food. The image shows a modern, high-tech vertical farm facility with vibrant plants growing under bright LED lighting. This innovative farming technique is revolutionizing the way we think about producing food, especially in space-constrained urban areas. Vertical farming is a method of growing crops vertically rather than horizontally, using controlled environment technology to optimize growing conditions. Most vertical farms use soilless techniques like hydroponics, aquaponics, and aeroponics to maximize space and resource efficiency. Vertical farming systems can be housed in a variety of locations, including purpose-built structures, converted buildings, shipping containers, or even underground spaces. The key benefits of vertical farming are its ability to produce more food in a smaller footprint, reduce water and land usage, and grow crops year-round regardless of climate. The history of vertical farming dates back over 2,500 years to the legendary Hanging Gardens of Babylon in the 1600s. European farmers started growing fruit against heat retaining walls to increase yields in 1999. Professor Dixon Desbommier proposed the modern vertical farm concept. Desbommier's revolutionary design showed a single skyscraper farm could feed 50,000 people. This timeline provides important historical context for understanding the origins and evolution of vertical farming. Indoor skyscrapers are purpose-built high-rise structures or repurposed warehouses optimized for maximum growing area. Shipping containers are mobile, modular farms housed in modified shipping containers, perfect for urban deployment. Underground spaces like tunnels and abandoned mines offer stable temperatures and protection from weather extremes. Vertical growing wall systems can be mounted in existing buildings, turning any wall into productive growing space. Hydroponics. Plants grow with roots directly in nutrient-rich water, no soil required. This allows for very controlled and efficient nutrient delivery. Aquaponics. A symbiotic system where fish provide nutrients for the plants, and the plants filter the water for the fish. A closed-loop, sustainable approach. Aeroponics. Plant roots hang suspended in air, and a nutrient mist is periodically sprayed directly onto the roots. This maximizes oxygen exposure for the roots. LED lighting. Specialized LED lights can provide precise light spectrums tailored for optimal plant growth and development, improving yields. These advanced growing techniques offer significant advantages over traditional soil-based agriculture, enabling more controlled, efficient, and sustainable food production. Our key technologies are what enable us to precisely control the growing environment and optimize plant growth. First, our climate control systems maintain perfect temperature, humidity, and CO2 levels for each crop variety. This ensures the plants always have the ideal conditions. Next, our specialized lighting uses custom LED arrays to provide the exact light spectrum that maximizes photosynthesis and growth rates. Our nutrient delivery systems continuously monitor and adjust nutrient levels in real time to keep the plants at peak health. Finally, our IoT sensor networks track every environmental parameter and plant health indicator, giving us complete visibility into the growing process. Together, these advanced technologies allow us to grow high-quality crops with unparalleled efficiency and consistency. Vertical farms can produce up to 10 times more crops per square foot compared to traditional farms, dramatically increasing yield and efficiency. The controlled indoor environment of vertical farms allows for year-round production, enabling consistent harvests regardless of season or weather conditions. Vertical farming systems use up to 95% less water than conventional agriculture through closed-loop, highly efficient water recycling. Locating vertical farms in urban areas significantly reduces the distance crops need to travel to reach consumers, slashing food miles and transportation costs. Vertical farms allow us to produce more food in a smaller space, helping to conserve natural habitats and ecosystems. Recirculating water systems in vertical farms drastically reduce water consumption compared to traditional field irrigation. By having a controlled environment, vertical farms can eliminate the use of pesticides, herbicides, and most fertilizers, making them a more sustainable and environmentally friendly option. Overall, vertical agriculture offers a way to produce food more efficiently and with a much lower environmental impact than traditional methods. High initial costs for infrastructure and technology required to set up a vertical farm. Energy demands from lighting and climate control systems can be a significant operational expense. Focus on growing high-value, quick-growing crops to maximize profitability. Local, pesticide-free products from vertical farms can command premium pricing in the market. Singapore is a land-scarce island nation, so urban vertical farms are an important solution to address food security and self-sufficiency. In Japan, abandoned factories have been converted into highly productive vertical farming operations, bringing agriculture back into formerly industrial areas. Major U.S. cities like Chicago are seeing the rise of urban vertical farms, integrating agricultural production right into the heart of the city. In Israel's arid desert environment, vertical farming leverages advanced water conservation techniques to grow food sustainably. Vertical farming is enabling food production in diverse regions around the world, from dense urban centers to arid climates, overcoming traditional land and resource constraints. Artificial lighting is a major energy consumer in indoor farming, requiring significant electricity. Current indoor farming systems are optimized for growing leafy greens and herbs, limiting the variety of crops that can be produced. Successful indoor farming requires specialized technical knowledge and skills that can be a barrier for some growers. The high initial investment needed to set up an indoor farming operation is a significant financial hurdle that can prevent wider adoption. Vertical farming has tremendous potential for the future, with several key developments on the horizon. First, we're seeing increased integration of renewable energy sources like solar and wind to power our operations, reducing our environmental impact. Secondly, AI systems are being leveraged to optimize yields and resource use, maximizing the efficiency of our vertical farms. We're also expanding beyond just leafy greens, exploring the cultivation of a wider range of fruits, vegetables, and even staple crops in our vertical environments. And importantly, as the technology continues to advance, we're seeing costs come down, making vertical farming a more economically viable solution worldwide. The world's urban population is projected to grow significantly, reaching 68% by 2050. As the urban population grows, the demand for food production will also increase by 200% compared to 1950 levels. Vertical farming can help address this challenge by providing year-round local food production that is protected from climate disruptions. Vertical farming dramatically reduces food miles and transportation emissions compared to traditional agriculture. This ensures a more reliable and sustainable food supply for growing urban populations. The future of agriculture will involve a blend of traditional farming and innovative vertical farming approaches to create more resilient food production systems. Vertical farms will become an integral part of urban planning and development, serving as core infrastructure in smart cities of the future. Advancements in technology will make vertical farming more accessible, enabling community-level farming initiatives to emerge worldwide. Vertical farming will play a crucial role in establishing truly sustainable food networks that minimize environmental impact and maximize efficiency.